Hi, good afternoon, and welcome to the ZP Developer Zone. So we often do the ZP Developer Zone at, well, sometimes we do at 8 a.m. on a Sunday. Admittedly, this today is, at least European time, is Saturday afternoon. We've just had to go early because of various commitments. That said, let me go straight into it. And just say that, we do this. I've got the date here, the 24th of March. I do appreciate that this has gone out a little bit early, but we are live streaming and we do like to kind of give that, that sort of authenticity of what's really on our mind when it comes to this. So the questions that we will answer today are about questions regarding ammonium sensors. Ammonium sensors will actually appear twice today. One of them will be for a particular application that somebody is keen for us to ZP to take a look at. And later on you'll see another question where it's actually regarding the detection of creatinine. So I will have ammonium sensors twice today, but bear with us. Question number 2 is about integration of LFA, lateral flow analysis, and electrochemical sensors. We've had a series of these kind of questions, and this is really part of that, and I will discuss that. Somebody else wants us to functionalize the screen printed electrode, or talk about functionalizing the screen printed electrode, so I will address that. Somebody else wants to do continuous glucose and potassium sensing. It's not something we've talked about for quite a while here, actually, but this is a watch from ZP. It's actually got an insert on the back of the watch. This is the insert, and on this insert there's actually micro needles that put these kind of glucose and potassium sensors through the skin into the interstitial fluid. It's not something I'm going to talk about today, but I will. It's something that ZP does do. I suppose I don't talk about it too much at the moment but we are ISO 13485, so we are sort of developers and manufacturers, contract developers and contract manufacturers of electrochemical biosensors. As I say, there's another ammonium appearance today, and this is ammonium sensors for creatinine testing, which I will cover. And then also somebody wants to know about rapid functionalization or rapid fabrication or customization of gold electrodes, which I will also cover as well. That said, let me go forward. Now we do have a webinar, and I will put a bit of a link to that webinar in a bit. We have a webinar actually next week. It will be featuring this SensiAll platform. So many people these days are very interested in doing what I call IVD, in vitro diagnostics or point of care type detection. This SensiAll platform will be very, very useful for those. Even the questions coming in from the students about, we want to do this particular analyte, etc. By the time you're ready to kind of commercialize in your actual careers, this technology is already there. And so suddenly the kind of gap between ideas and creating companies and doing spin-outs will have been dramatically decreased or eased because of platforms like SensiAll. I'm not going to be putting QR codes up today, but there's a webinar anyway next week, and I will put a link to that. So please come to that. That said, let me go forward a little bit faster and just say here's that webinar. It's on the 26th of March. We do one in the morning and we do one in the afternoon European time. The only reason is then it gives people around the globe an opportunity to attend live, because we like to do those webinars live because it kind of demonstrates the robustness of the technology stack. So there'll be one in the morning, one in the afternoon. At ZP, if you're kind of commercial and you have questions beyond just buying products, then ZP is we have a consulting arm. So we can do contract consulting and we have labs, we have manufacturing, so we can do contract development, contract manufacturing as well. We also have workshops as well. So if people are interested in making kind of CGMs, that's continuous glucose monitoring, or wearables, or even IVDs, we do workshops every month in Norway. And we also come on site and do workshops at people's sites as well. So I said there were 6 questions today. Question number 1 was really about ammonium. So somebody wants to make they have an application where they want to measure. I don't think by the way, these are not low concentrations of ammonia, 50 to 30 milligrams per liter. In my world, that's, these are quite high concentrations. That's 50 ppm to 300 ppm. These are quite high concentrations in my world. Sensors need to be robust. Some of these questions are about our technology, and some of these questions are about your application. So ZP has technology and you have an application. There'll be a gap between what our technology does and what your application requires, at which point then you can either close that gap through your sort of own efforts, your own engineering, or You can engage ZP to close that gap, or you can have a hybrid where you're kind of partially paying ZP for advice or consulting or doing work, and you're also using your own team as well. But the reason I bring that up is because, you know, if you've got a particular application that maybe requires longer cables, or you need to be within that bioreactor, then that's really an application question. You do ask a question, no, not our sensors, for example, ammonium sensor, you can dip it into the solution and measure it that way, or you can put 50 microliters onto the sensor. But bringing the and I've got a sensor in front of me now. Bringing the sample to the sensor is one way of doing it, or bringing the sensor to the sample is another way of doing it. So sample to sensor, or sensor to sample. You don't have to think you're restricted to 50 microliters. Can you do continuous measurement over a couple of days? Now, I will, in the next slide, bring you out the data that we do have. ZP has done much longer runs of our ammonium sensor, but we've done that on client paid projects. So I'm not going to be bringing that data to this slides today. What we have in the public domain is what we have in the public domain. If people do engage us on projects, then we can, you know, dig into this a little bit deeper, but those are paid projects. Do I need to buy the potentiostat board, the 10 sensors to have a working solution? See, if you buy ammonia sensors from ZP, the ammonia sensors come as is. If you buy the single-purpose biosensor board off us, they come as is. It's then for you to make them work in the application, unless you otherwise engage ZP. ZP does do a proof of principle type project, which is 111 hours. So we could probably do what you're asking to do in that kind of, you know, 111 hours from ZP. We could probably at least do a proof of principle on your application. Do I need to calibrate the probe before use? The quick answer is, if you're engaging ZP in a program, we can probably show you how you don't have to calibrate the probe before use. But if you're not engaging ZP in a program, you're buying components off in it and doing it yourself, then it's a problem that you'll have to try and figure out. But otherwise, ZP probably doesn't know how to do that. How many samples can be tested with each probe? What is the lifespan? That really depends on the application. That's an application question. That's not a question about ZP sensors. What I mean by that is, see, biosensors are unlike most other technologies, or unlike other sensors. Like a temperature sensor is not necessarily in wet contact with the sample. So your solution is your solution. Your pH is your pH. What other proteins are in there is you've put those in there. So for ZP to make a blanket statement about how sensors will behave in people's particular solutions is not really possible. There's too many combinations of chemicals and pHs and salinities, temperatures, all sorts of parameters that we wouldn't otherwise know. And even if we did know them, the only real way of answering the question is you have to try. The thing about ZP and its technology stack is people can try things very quickly. Otherwise, you're kind of always asking these questions, will it work? And you'd have to kind of essentially almost maybe impossible to go forward, because you'd have to build everything from scratch. Well, with the ZP web store, things are on the web store. You can buy them and try them. I always like to sort of quote MIT, fail fast. You say here, can you SPI or I squared C interfaces? I will also link to the data sheet as well, so you can answer that question. One of your first questions was actually about that range. So this is the data, this is the link. I've done the units conversion to you. I should have put, that's 1.8 milligrams per liter, or 1.8 ppm. 18 ppm, which is 18 milligrams per liter. 180 milligrams per liter, or 1800 milligrams per liter. So we definitely cover your range that you otherwise quote. You're asking for days, and as I say, we've got longer time periods in our data sets, but these are gathered on client programs. So the business model of ZP is that if people want a light engagement with ZP, they can just come in and buy technologies. If they want an easier, more successful route, then they're possibly better off engaging ZP in a paid program. But we do put the stuff on the website and allow people to, especially our academic colleagues who don't necessarily want to, have a large engagement with ZP, but more commercial operations often prefer a more deeper engagement, because time is essentially money, so they'd rather spend the money and make sure they're more successful. you can do discrete measurements with our ammonium sensors as well. You can have one of these kind of kits, and put a kind of a 50 microliter sample on there and measure that. But I understand for your application, you don't want to run in this configuration, so you're not obliged to run in this configuration. But otherwise, I think you actually need components. This is a program that we've been doing recently. I'm not going to discuss the program, but we have been sort of taking our kits and putting them into unusual applications, and having cables like half a meter long was no problems in that particular program. So I'm going to put some useful links up to you. So it's kind of buy and try it out in your application, or you can engage ZP for something like 111 hours to sort of have a go at your application. And if you see any links jumping up, I'll make sure I put the links underneath the video as well, because it's probably worth saying that there's 3 things here. There's technology readiness level. Some of ZP's technologies, this is a technology, it's an ammonium sensor. This is at a high technology readiness level. I could describe its manufacturing readiness level. This is a ammonium sensor. It has high manufacturing. We can produce this in high manufacturing. But your application is your application, and so you are probably in the beginning phases of your application. So with an application, you would buy in components. Some of them may come in from ZP. You would integrate them and you would start developing that application. But you can't come in at that application at kind of an application readiness level 9. You have to kind of earn it and get yourself up there. I think with ZP consulting or contracting, we can get people up their application readiness levels much quicker. But that is a kind of financial, and also have to look at internal resources as well and see what you want to do. Question number 2 is about integration of electrochemical sensors with lateral flow analysis. I think this is something I've been interested personally. Probably I don't want to be sort of sounding too old on this, but it's at least a decade I've been thinking about this myself. It's nice that people are also, other people are also interested in this. These people had a bit of a thing that they've got a connector off us, and they might want to trim away the plastic here. I can't absolutely say whether that's going to allow the connector to work or not. I'm wondering actually if you flip that connector over, there's some screws you can unscrew it and have a little look in there in that connector block and see if that's something that you think will happen if you kind of laser ablate away that housing. I can't advise you to do it, because if you damage it, then you'll get kind of mad with me. But I can understand that that's blocking your usage of the lateral flow strip. So I'd probably have to unscrew it and have a look in there to see whether you could trim away that extra bit of plastic. But we do have these other cables as well. But I'm also concerned that they'll end up blocking your what you're trying to do as well. So we do have some cables. I think you may be using a little blue potentiostat from a well-known potentiostat provider. On those potentiostats, they use what we call LEMO connectors. They have what's called 4-pin and 5-pin. So there's another way of maybe connecting with them. And I'll put those links underneath the video as well. But I'm not absolutely sure that that's going to do as well, because I'm worried that it'll end up blocking more of the screen printed electrode than you want to block. Now, I suppose I jumped into it a bit, but the integration between lateral flow and screen printed electrodes, these carbon electrodes are probably a good configuration for it. I know this is probably a bit small on your screen actually, but I realize this is quite a high res image of a screen printed electrode from ZP. Because in a bit you'll see a screen printed electrode, that's a picture of a screen printed electrode from somebody else sent me, and you'll see the difference in the sharpness of this screen printed electrode. That said, let me go back to the question. So the person's kind of interested in whether we could do a kind of lateral flow electrode combination where you put the sample on and then actually you could test several analytes at once. I mean, that is theoretically, let's say, possible. I'm always slightly reluctant on taking people on that journey of customization. But ironically now, I realize that question number 6 today actually does give an idea about how to do customization more readily. So I will go to that. Now, this is not that, I wasn't expecting to say this, but that's why I like going live, because actually, I don't like doing customization on screen printed electrodes. Now, why is that? Well, it's because every time you do customization, you have to make bespoke screens, There could be at least 3, maybe 4 screens involved. You know, that doesn't sound that bad in itself, but you know, there's a cost involved. You can't iterate. You can't sort of, oh, that screen didn't work. Oh, let's do another one. It doesn't, you know, it doesn't really work like that. So I do try to ask people in screen printed electrodes. Everyone's asked for customization, and I say be really, really careful about asking for customization on screen printed electrodes. You'll find plenty of vendors that do it. ZP will do it, but in the first instance, I say really try our screen printed electrodes. But actually, when I think about question 6 in a minute, there's an alternative technology that might allow you to do customization. That said, I will go forward a little bit more now and say you can do serial the way that I suggested on the other image. You could also try parallel as well. Now, I haven't looked it up, I haven't Googled, but I seem to remember there's a gentleman called George Whiteside who's fairly famous in microfluidics. I'm pretty sure he's been doing paper microfluidics for a few years. And I haven't read a paper on it, maybe I have, but it was very briefly, that he may be using wax in order to kind of help channel liquids along paper. So rather than just a liquid spreading out everywhere on the paper, I think he may be using wax as the sort of essentially channel, because you could see the sort of hydrophobicity of wax keeping liquids where they want to be. So imagine yourself with a sheet of nitrocellulose. I hope I get that. Yep. And you want to make a sort of lateral flow type technology on it combined with electrochemistry. So here's your lateral flow material. You can kind of make this parallel type system as well. So these people that I'm directly addressing at the moment, they bought some screen printed electrodes off us, they bought some connectors off them. You know, we kind of exchange ideas, you know, and then I reflect on their questions, and I sort of put some ideas back, which is what I'm doing at the moment. And this kind of idea that I'm putting here is, I'm going to put a link underneath, but I just want to inspire you a little bit. This is a kind of credit card idea that we may have had on the internet now for 7-8 years, quite a long time. And in this, now we're directing the solution down to these parallel electrodes, which happen to be very close to what you're using. So there's a kind of, not more than a coincidence. You can see we've been thinking about this for a while. And what you'll see in the video is that the solutions will fill up these wells. Well, now you could do a paper equivalent of that. So rather than using microfluidic channels to do that, you could end up using lateral flow material. So you can go in a serial configuration, or you could go in a parallel configuration. And it's probably worth waiting on for question 6, which you might find quite interesting as well. And I wasn't really thinking about the connection. Again, if a link pops up, please click the link later on. Question number 3, this is an interesting one. So somebody's trying to functionalize a screen printed electrode. I mean, I applaud, you know, screen printed electrodes. If you want to make a commercial, at least IVD, an in vitro diagnostic or point of care use sensor, screen printed electrodes are good. Don't go for customization straight away, but otherwise they are a good platform. This person wants to functionalize it. And I will talk about this as we go. So this is one of our 501s, and I will link to this 501 in this presentation or this webinar, and also link to it underneath the video as well at the end. So this is a 501. I would argue that actually and I should drag myself slightly out of the image as well. I would argue that you can see the kind of quality of print here, that, you know, this is fairly sharp, all the distances, there's no shorting. Now, I will answer that person's question, but I did ask them to send me an image, and I've kind of, I've copied up the brand on the image because, you know, I want to do that. But when you look at this, the biggest problem with screen printed electrodes outside of ZP screen printed electrodes is actually reproducibility. I will talk about this in a minute, but ZP makes a very reproducible screen printed electrode. Why? Because, in fact, we use screen printed electrodes a lot. This is the manual for one of our products called FoodSense. FoodSense is for monitoring food ingredients. So we do use our products a lot with our, let's say, clients. And at the same time, then we put the screen printed electrodes onto the web store, and we help the development and the academic community. That said, see, we work a lot on reproducibility. So when I look at this, I can sort of compare it to the sharpness of our own print. And this is very, very printing. You know, it's very hard to argue that the electrodes that are coming from this batch of electrodes will at all be reproducible. So be really careful with screen printed electrodes, because you can spend a lot of time trying to make assays and biosensors upon them. But if these electrodes are, and this is not one of ZP's obviously, and I've covered up the brand on this, but if this is, we wouldn't ship this. It's not reproducible enough. And there's an extra issue with it that, we all know how a potentiostat works. You're trying to control the you're trying to control the working electrode versus the reference electrode. These are shorted. It's clear just by eye that if it's not hard, it's not a hard short, it's definitely a soft short. These two are touching. That's really going to mess up your ability to use instruments with this screen printed electrode. It's not going to function in a traditional electrochemical sense. So your question is, how do I functionalize this? My answer is, these electrodes are going to give you a lot of heartache. They're not, you really can't use these, especially with they've got gross defects like the short here. So my warning is not to use them. Now ZP, we do actually carry a lot of screen printed electrodes, just like well, not a lot, but we do carry them just like the functionality that you have there. And whenever you look at our screen printed electrodes, you will find that they're actually, the resolution on the print is really good, and I've put links to them here. And if you come to our webinar next week, so I did put a link earlier on, or I put a slide up earlier on about, we have a webinar next week on Sense It All. If you come to it, you'll see live demos, and you'll see no calibration. When people do calibration in academic papers, it's often because the underlying either screen printed electrode or functionalization is not repeatable. In your case, your functionalization, doesn't matter how repeatable your functionalization is, that electrode is unfortunately so irreproducible, I would suggest, that you will not get a good assay from it. But you'll notice in a lot of our work, actually, we don't do calibration. And why is that? Because when we make these screen printed electrodes, we do a technique we call wafer mapping. We sort of essentially get the sheets, we check some of the population of the sheets by voltammetry, not just on one sheet, but on several sheets. We have a data and analytical system called Julie. Julie is something you can find online. You can register for it free online. And Julie is our tool so that we don't have to crunch through. We must collect thousands of data points a week. We don't have to manually look at it. We can upload it to Julie, and Julie will crunch it for us. But what we're doing is we're making sure that our RSD, our relative standard deviations, are low enough that those screen printed electrodes are going to be functional in assays. So with those different sheets, we look at the mean peak height, we look at the relative standard deviation, and we kind of plot it across the batch to make sure everything is staying reproducible. So the answer to, so you're asking how to functionalize it, and I'm saying it doesn't matter how good you get at functionalizing it. If that underlying screen printed electrode is not reproducible, then essentially you are, unfortunately wasting time. Now, time in the end, we only got a certain amount of time in life, and that, it's essentially wasting time and money. So I would be very careful. So this is an assay that we did on our own screen printed electrodes. Every color represents a concentration. Every concentration is done in triplicate, so you can see the kind of reproducibility of those screen printed electrodes then translates over to the assays themselves. So in answer, if we're functionalizing a screen printed electrode, one of the best ways of doing it is just a drop cast. I know it's such an obvious thing, but we would take that screen printed electrode, we would drop cast onto that working electrode, we would dry it under controlled conditions, and we would leave the functional material on the surface afterwards. Now, we might do that in a controlled temperature and humidity, and we might do it by robots. So I know I'm stating the obvious there, but what I did, the reason I wanted to kind of bring you into the webinar was to just say that screen printed electrode is too irreproducible, and it has gross defects on it, like shorting. And so you really can't use that in your biosensor development. It's just going to, I'm not sure if it's going to damage your instrument, but it could damage your instrument. So be careful, especially because the working and reference are actually shorted together. Question number 4, somebody wants to do glucose and potassium measurement. If anyone's interested in glucose and potassium and they're kind of well funded, ZP does actually have 50 patents on the continuous measurement of glucose. This watch has had like $20 million US spent on its development. It's something that we do license into client programs. I think this is the slightly sportier version. These watches, by the way, are not, the FDA's just put out a bit of a note actually that they're really warning people against non-invasive glucose monitoring. So in that FDA article, they do actually mention, you know, it's got to break the skin kind of thing. So be careful, because when I sort of flash this watch around a little bit, this is a microneedle system. It does actually break the skin. Anyway, that said, if you're not funded, we do have technologies that you can put together and start making continuous monitoring systems. So here's for glucose, here's for potassium, here's the circuit, here's the test solutions, and hopefully that will help you. And I will put the links underneath the video on YouTube afterwards as well. Question number 5. I like this question. Somebody wants to make a creatinine sensor. They've identified that there's creatinine deaminase. Creatinine deaminase, in fact, I've got it here, takes essentially, replaces the amine group here with a carbonyl group here, and we get ammonium released, and you could, theoretically detect that. And you are 300 micromolars. Yes, 300 micromolar. Yeah, 30 to 300 micromolar. It's probably worth saying that we've got quite a strong signal on that ammonium sensor from 0 to 0.1 micromolar. So I've got the data on the next slide. So let me just jump to the data, because I've just realized what units you're in. You're in 30 to 300 micromolar. So yeah, 0.1 millimolar is 100 micromolar. So I think, you know, you're essentially trying to detect below, well, this is 0, so you're trying to detect above this, and you're trying to detect above here. So I think I'd have to have a little look back again, 3300. So yeah, I got a suspicion that the sensor actually would have the, well, I know it has, because this is 1,000. You are saying micromolar, not millimolar, aren't you? You're saying micromolar, yeah. Just keep checking my units, that's all. Yeah, so this is 1,000 micromolar up here. So 100 micromolar, 0. So I've got a strong suspicion that the ammonium sensor essentially will do the job. Because, you know, in the end, you've got to look at what you're trying to achieve. You're trying to achieve something in a limited time, limited budget, and you just want to kind of prove the principle a little bit. So this is a fine strategy to do. If you were really trying to do in a commercial setting, you know, a sensor that was going to be used in human health, I might argue that you would look at this a little bit stronger, but for what you're trying to do in the context of it, I think it's perfectly fine, and you know, you get to learn along the way as well. But the quick answer to your question is, I think you don't have to use our ammonium sensors. Of course, you do not have to use ours, and actually, I don't expect you to, because to be honest with you, you know, in that kind of university setting, I know everyone will do it themselves. But that said, at least I think the idea is definitely has merit, and I could at least see us doing a proof of principle at ZP if we were doing that in our labs. Yeah, we would in principle make it work, I suspect. And I will go forward a little bit and just say to you in particular, this is just for the future, but please come to our webinar on the 26th of March. It's just going to talk a lot about, I always like to talk to students about, you know, the future, let's say. You know, you've got programs on now, but what you're going to do in the future, and this will just give you a sense of how to commercialize assays. And actually, in the end, if electrochemical assays, especially if they, you know, on platforms like this, don't leave the lab and end up helping people in the real world, then, you know, I think it's essentially failed. So please come and please learn for the future. I'd be delighted if you attended. Question number 6 is about, and it's interesting because I did say to the person on lateral flow, this is something I didn't see the connection until I started the webinar, but we do get a lot of requests for bespoke electrodes. Now at ZP we have a lot of very good screen printed electrodes, but I think that's, I know I say it a lot and I've said it already in this webinar, but in life, if you're going to start iterating, you need to be iterating fast and failing fast. You can't have a slow iteration cycle. You know, I come across a company recently where their iteration cycle is 6 weeks. You know, I've said to them, you've got to have an iteration cycle of 4 days. Otherwise, you spend 6 weeks. Oh, it didn't work. Oh, well, let's spend another 6 weeks. It didn't work. No, that's not the way things run. But I am going to talk about a technique here where actually you can try out different electrode configurations only in gold quite quickly. So I want you to imagine a square. I have to remember myself. This square is 50 millimeters by 50 millimeters. That's 5 centimeters by 5 centimeters. Within that square, there's 400 squares, so it's a grid. So it's a a massively ridiculous large chessboard, but everything's on the kind of millimeter, if not micrometer scale. And those squares actually have a length of 250 micrometers. So I'm talking about a space here. Imagine a gold continuous layer that is 5 centimeters squared, and from this material we can actually, and it's on a polymer, quite a thin polymer, so you can flex it around, we can go into there and address those squares. So let's say you had a design like this. We know the dimensions of it. You can actually lay out those kind of designs within that square, and I haven't laid it out in the most optimal fashion. I can definitely say that for you. I have not laid out in the most optimal fashion, but I'm just showing to you that you can actually lay out several electrodes in this square. And I realize that, yes, I'm just about right on that, but only just about right. 7, 14, 21, 28, 35, 42. Yeah, I was just counting to make sure I do my maths correctly. So you can lay them out like that. Just out of interest, if you do start doing bespoke electrodes, many of the potentiostat manufacturers and the screen printed electrode manufacturers have a sort of standard connection dimension. It's good to stay within those standards. So I'm just putting these up here to sort of show you the pitch, the length, just so if you do design your own bespoke electrodes, that you try and stay within our sort of design rules. It'll make your life easier when you're trying to connect to instruments. Yeah, so I just sort of say that. The way this works is you've got this continuous gold film, and essentially what we can do is we can actually come in here and address it and actually take away the gold in certain squares. So it's actually a very flexible way of, it's not super fast, but it's super flexible. This is essentially digital removal of actually the gold. So we can remove gold, and then we can actually make designs, as I say, like this, and then we've kind of used a laser then to cut away. It's not super fast, but it does allow for a lot of flexibility. So that's a new way of, for ZP at least, at fabricating at least electrodes in gold quite readily. So questions this week, right? Ammonium sensors. So the ammonium sensors are available on the website. The potentiostats available on the website. Test solutions available on the website. The data sheet I've linked to. Most likely to succeed is to engage ZP, but otherwise you can try and buy and try and go yourself on that ammonium sensor for your application. But just understand that what we have in the public domain defines what ZP has. Your application, I can't extend what we've done to what you've done. Somebody has to do the work, and so somebody will have to do it. Otherwise, I'm just speculating, and I'm too much of a scientist to just speculate that we can, that everything will go really well first time round. In fact, I'd be super surprised if that was the case. With your lateral flow question, nice question number 2, I just wanted to show you that there was another way of thinking about that, and that was that parallel design as well. I hope the video links and stuff, I know you listen and it's great, so I hope that's inspiring. Share it with your supervisor. I'm happy to answer questions. Functionalizing that screen with the electrode, I know I said it, it's just so obvious, but we're depositing down onto those working electrodes. We're also using sometimes that circular electrode, so it makes it easy pipetting. But that electrode that you sent an image of, it's shorted on that reference and working. It will never work in a traditional electrochemical biosensor. It could end up damaging your instrument, so be super careful about it. Continuous glucose and potassium, I have given you links to the glucose sensor and the electronics and the test solutions. If you've got any more further questions, don't hesitate to reach out to us. If you're super well funded, let me know, because we do actually have a very robust way of doing that, but we are looking for partners that are well funded on that work. Ammonium sensor for creatinine testing. I'm pretty sure that the data that I've put on those slides shows you that the clinical range that you're interested in is covered by the ammonium sensor. I don't expect you to get the ammonium sensors necessarily from us, of course, but just putting it out there that I think the idea's got merit. If I was commercially doing it, I'd probably have a harder think about it. But I honestly think that, it's all about time, money, and quality. See, so you haven't got that much time. They won't give you that much budget, and it'll probably be good enough in terms of what you're trying to do, and those just achieving that kind of goal of having a successful program. I think it's fine doing what you're doing. And then just finally, somebody wanted to know whether we could do rapid fabrication customization of gold electrodes. The quick answer is we would. And I wouldn't necessarily do it in screen printed electrodes. I'd be using that digital removal technique that I was just alluding to just then. So I will finish it with that. What I'm going to say is thank you. You can see that at ZP, if we get questions, we do actually generally think about the answers. We try to illustrate, pull stuff from the web that's relevant. And if you've got any questions, I would say don't hesitate to reach out to us. Okay, thanks very much.
Kyle, go down with the big TNT. Don't explode my base. Because that big TNT is
Thanks very much.
real. Yeah. I might do something to stop me flying. I made this command. Yeah, you got to